welcome here. Yet another meetup. The regular question every time, like, who's here for the first time? So I'm pretty happy with the sort of rotation and moving people around, the power in my hands. So it's been sort of interesting. We've been running these meetups around any kind of technology since early March. And we started with a talk from Google. Since then, we haven't had one. It's only been other people talking about other stuff, which has been really interesting. So, and I want to make sure that the meetup was actually about interesting technology as opposed to this is just our latest product or something like that. But I probably even took it too far because it got to the point where people started asking, like, couldn't you actually talk about what you do as well? Which is probably a good problem to have when people are at least remotely interested in what you're doing. And I think this is kind of an exercise for me as well, with having my colleagues Henrik and Patrik here presenting tonight. So this is actually kind of my sneaky way of finding out what they're actually doing. I know how they play floorball, for instance, and certain other skills, but no idea what they actually get paid for. So with that said, we'll have a presentation for about 45 minutes ish. It's always ish. And then do a Q&A. And it gets to the point when half of the people are trying to sort of sneak up behind the curtain, we'll stop, and then we can continue in the kitchen. If you want to go home, you're more than welcome. Otherwise, you're free to stick around where we had the food and just talk more, share ideas, and ask them questions, at least for as long as you're going to stick around. You get paid for that too, right?
I don't know.
But not by me.
So.
It's not my budget. So anyway, it's actually going to be really interesting and on a sort of scale-ish level and talking about doing hackable things. So take it away.
Thank you, Robert. Okay, so at Google, we like to talk about something we call the concept of hackability. And what it means is essentially that the project is easy to work on. And there are a bunch of qualities that define a software product that's easy to work on. So we're going to try to cover that for you today and give you some ideas of what is important to set up in a project to make it successful. And we're going to dive into a kind of wide range of subjects. We're going to talk about the infrastructure you need to run your tests and how you write tests and a bunch of stuff. So I think everybody's going to be able to take something away from this. So I'm Patrik, and this is my colleague Henrik. I'm something called a Software Engineer Tools and Infrastructure, or an SCTI. That means my job is to make developers productive, essentially. That's maybe the one-sentence description of that job. It used to be called SCT for Software Engineering Test. Now it's SCTI because I don't write tests, or well, I do, but it's just one of the things I do, really. And Henrik is a test engineer.
Yeah, I'm a test engineer and work mostly like on build system, continuous build, infrastructure, tools, and I do a bit of test planning and execution as well. So we encourage you to interrupt us with questions at any time, and we even encourage to tell small war stories about when we ask things and the stuff that's related to what we're going to tell you here. So
yeah, we're going to talk both about great development environments and terrible development environments, and we're interested in hearing your stories as well. Maybe everybody can learn from that.
So the agenda for tonight is we're going to divide this concept of hackability into 3 different pillars. So the first one is code health, the next one is debugability, and the last one is about the great infrastructure to support the project.
Okay, so we looked up the following definition on Wiktionary. Hackable is something that can be hacked or broken into, insecure or vulnerable. That is not what we're talking about tonight. We're not going to talk about rolling your own crypto or binary parsing or other stupid things you shouldn't implement yourselves. We're going to talk about that. Something that lends itself to hacking, which is technical tinkering and modification, or is moddable. That is easy to try things on and work on, in short. So to give you an idea, what is hackability? When everything is great, here are some examples. It's a general feeling that development is easy. You know, you can write code and something happens, and what happens is what you expected, more or less. Well, you need to be moderately skilled as well, but you know, but at least stupid things aren't stopping you from doing the thing you want to. You have a fast build system. You build and then it's done, and then you can run your thing, and it doesn't take a long time to build. You can run tests. There are tests to begin with, and they are fast, and you can run them, and they're easy to use. The code is clean and easy to understand. You can read the code and very quickly grasp what it's doing. It's easy to run whatever you're running and debug it. And if you make a change and it turns out you broke something, you click one button and then you can roll back whatever you did. Or maybe someone else, like a build sheriff or build cop or whatever you call it. What is not hackability? For instance, you come in on the Monday morning and update your checkout to the latest revision, and it doesn't work. Like maybe it doesn't even compile, or the application doesn't boot, or it's broken, or audio is broken, or you know, whatever. Screen share doesn't work like you expect it to, or no, that's not a good example. But like if you, I mean, if you come in and get stopped by things like that, it's not a good thing. And in general, people shouldn't even be able to. We shouldn't even be able to get to this state. There should be something that stops you from doing this. And there are like varieties to this problem as well. Like for instance, when me and Henrik started on a WebRTC project, there was no continuous integration in place. Really, you just had a bunch of test binaries you had to run by hand. And generally, things work great on Linux because that's where all the developers were on. But Windows could be broken for days on end and nobody even noticed. And that's not a good place to be in. So then someone gets a bug report on Windows. Oh, I need to fix this bug report. And then, oh, it doesn't even compile. And then they need to fix that first. And then they can solve their bug report. So either way, it's bad. Or if you have tests, the tests are there, but they're slow. That's also bad. If things take time, too much time, you get the long feedback cycles, and that's not good. Also, if a build takes hours to execute, I don't know, the worst I ever heard of was an operating system, embedded operating system, that took 24 hours to build, like fully. So imagine that you fix a bug in this operating system, and then 24 hours later you get the answer, no, it didn't work. That's not a lot of fun, right? Or like if you work in a C++ program or whatever, and building and linking takes more than 10 seconds. I think that's my personal limit, at least. Like if it takes more than 10 seconds, then my attention tends to stray a bit, and I maybe hit off Aftonbladet or whatever. But if it's less than that, then you can kind of stay in the flow and keep working. Or maybe you want to really understand what's going on. Like that variable cannot possibly be free, for instance. And then the best thing to do is attach your debugger maybe and look at it. But maybe there's a limitation in your project, so you can't attach the debugger, and so on. Or like suppose you have a backend with a bunch of servers and you're running it, and you can reproduce your error, but you get 15 megs of logs, and there's a lot of warnings in the logs that aren't warnings really. It's just spam, and then it's the signal to noise ratio is terrible in the logs. That's also bad for hackability. Like I don't even I need to spend a half a day to understand how the logs are written to understand what the root cause of my problem actually is. Do you have anything, like what would you add to this list? Like what really hinders you in your daily development?
That's a good example, yeah.
Yeah, we're going to talk about that later. Traceability, like
poor naming generally.
Yeah.
Poor naming of branches, poor naming of repositories, poor naming of everything.
Yeah, and even the code itself. it's hard to read if classes are poorly named or methods.
Luckily, we have a recipe for both these problems that we're going to talk about.
Yeah, we got it all covered. Maybe.
Anything else?
Things mashed together. Like you don't know it, but I'll just stick it into this class because it doesn't look that good, but it works for now, and it's there for like 10 years later.
Yeah.
We have a recipe for that too. This is great.
Yeah, that's right. God classes, right?
Structure.
Yeah. The worst God class I ever heard of was I worked at Ericsson, and we had a class, and the class could unpack software, send it over the network, pack it back up again, parse XML, and send email.
Excellent.
And it was 6,000 lines. Yeah, I think actually the definition of a Unix program is if it can send email, and if it can, then it's a super advanced program. Yeah. Okay. So hackability means it's easy to try things and it's hard to break things, at least inadvertently. Okay, so that leads us into our first pillar, code health. And the code must be readable is our first.
Yeah. So for addressing stuff like the bad commit messages, as an example, and maybe also this sneaking code into somewhere where it doesn't belong, the recipe for that is just to enforce code reviews. That's at least our opinion. So I just wanted to check, like, how many of you have mandatory code reviews for all code in your project? That's almost half of the audience. That's great.
And pair programming counts, kind of.
Yeah. So it really enforces good quality, and it has a very good advantages that are like not really well known. Especially can be hard to encourage management and so on, because like, oh, this is just going to slow us down. Why do we have to do this? But if you know that someone else is going to read your code, you really write it in a different way, and you're much more careful, and like stuff like naming and doing hacky things, quick dirty fixes and so on. It kind of gets stopped at the code review stage. And of course, if it's really an emergency, stuff should be allowed to like bypass or at least review after committing the code. But still, it's a very good gatekeeper for bad things. And it also encourages you to make small changes, because you're going to review other people's code and they're going to review your code. And you know that if you get a huge code review, that really sucks. It's hard to do a good review, and it takes a lot of time. So it encourages small incremental changes. If you do a refactoring, you maybe do it in 5 different code reviews and submit each. And then you get test coverage for that, and you let it bake a bit in the build before you continue with the next one, and so on. So it reduces the risk. It's also a very good way to spread knowledge in the team, because I guess all teams have senior developers and junior developers, and usually the seniors are the ones that do most of the code reviews, and they can explain design decisions and prevent the design from really diverging over time. Also, a good thing to verify in the code review is that the code really follows the style guide you picked for the project. This allows more consistency in how the code is written, and makes it more readable, which is certainly a good thing. And at Google, we have something that we call readability, that every review needs to have been looked at by someone with the readability in the language the review is about. So readability is a per language thing that you acquire by proving that you can actually write code in the language, but that you also know its idioms. And
it's idioms and it's culture and how we write in that particular language at Google. Like, for instance, Google C++ uses a limited subset of C++, because if we didn't, it would be insane, right? Because C++ is pretty insane if you use all of it. So that is an example.
Yeah. So that really also adds to this in a good way. And moving on to tests.
Yeah, next thing for code health, you need good tests. And this is one of my favorite instructional slides. It's called the testing pyramid. You may have heard of it earlier. It essentially suggests to you how you should structure tests in your application. And of course, tests are, all products are different, but in general, you want something like this. And that means like maybe 80% unit tests, 15% integration tests, and 5% end-to-end tests. And integration tests here means tests that test several classes or translation units together. You need a solid foundation of unit tests in your product. That is great for hackability for a number of reasons. One reason, which I think is underappreciated with unit tests, is they allow you to run a small piece of code under very controlled conditions, and you can see exactly what it's doing. You don't have to boot a 5-minute to boot server to see if your code change work. You just run the unit test, and it takes 5 seconds. And the unit test is still there when you after you're done hacking on your thing, so it's going to prevent other people from breaking it. So in general, they provide amazing value. But writing unit tests in a code project, such as a Java project or C++ or Python or JavaScript or whatever, is hard, because you're required to structure your code in such a way that it is unit testable. For instance, dependency injection and such things. So often we end up in an example where unit tests don't happen for whatever reason. And often it's the case that people feel that we don't have time with that, or we're just doing a prototype or whatever, and then suddenly that prototype is a released product. That's often what happens, right? So how do you make unit tests actually happen in your project? This is something that's part of my role, for instance, is to encourage people to do that. And I think there are two things you can do. You can lead by example, and you can educate and coach people to do it. Leading by example, for instance, we started up a new mobile app here at Google very recently in our team, and I managed to get a unit test in there very early. It was a stupid unit test that didn't actually test that much, because there wasn't a lot of code to test anyway. But I did a work of like setting up so that it built, that you could run it, and even though it was running in continuous integration pretty early. And I also wrote a early UI test. So this was an Android app, so instrumentation tests and Rob Electric unit tests. And I think that really helped people get started, because they noticed, oh, the test is there. I can just add a test to it. That is awesome. And then I kept writing more tests to sort of demonstrate how to write a good unit test. And I think that's very powerful, because think about it yourself. When you write code, you often do it by looking at the surrounding code, right? And kind of extend and modify that. So if there is a unit test there, it's quite likely you're going to add another one, for your new class. Or and the second thing is educating and coaching people, because, like I said, writing unit tests is hard. You need to know what is dependency injection, what kind of patterns in code prevents unit testing, such as global state and singletons and other bad design practices. So you need somebody to take charge and mentor people and suggest refactorings when the test isn't when the code isn't testable. That's very common, I think, particularly with so-called legacy code. I think often in projects you encounter resistance towards writing unit tests as well, or maybe you feel that resistance yourself. It's like, nah, I don't see how that benefits me. But often it's what you need is some encouragement and education in how to write them. And I think when people get that education, they find it's awesome, because, like I said, you can run your code really fast. And if you're working on a large product, that makes a lot of difference. And this is something you can insist on in code review. Like in Google's style guides for all the languages, it says everything should have unit tests. So that's a good style guide principle there. Okay, but we know how it is out there. You have legacy code. Maybe somebody else wrote it, or maybe you wrote it, whatever. But it doesn't have tests, and it's a mess of global state and static calls all over, and messed up dependencies. The answer to that is refactoring. And something I really recommend is this guy, Mishku. He's a Googler working in Mountain View, and a couple of years ago, I think around 2009 or something like that, he wrote a great guide on like what is common pitfalls when you write code that makes it not testable, and how do you fix it. It's right there. So you can either try to remember that name, it's pretty unique, or maybe we send out the slides afterwards. Do we?
Yes.
Okay, good. Then you can just click the link there in the slides. I encourage you all to really do that. And that is mostly in Java, but it really applies to all languages except maybe Python. End-to-end tests, maybe not so much. You shouldn't have very many of them, at least. If you work in any kind of professional large projects, then adding end-to-end tests seems like a really good idea. That simulate what the user is actually doing, like clicking on buttons in your app and talking to a real backend and stuff like that. They sound like a good idea, and managers love these tests. It's like, yeah, now we can release our product and know it's not broken. Only it doesn't work out in practice so much. So since end-to-end tests involve the entire code base that you have, including the login system and databases or what have you, there are a lot of things that can go wrong. And many times the things that go wrong aren't actually bugs, but rather, that the test environment wasn't maintained enough for. And even if it does work, it's only going to work as good as your product works. And maybe it works well, or maybe it doesn't. But it's still hard to write the test so it isn't flaky or slow. So it can work if you write them carefully. But I would say, don't write unit tests. And then when you have 75% coverage, then you can start writing this.
Yeah. With the poor branch naming, my recipe for that is don't have branches. Single branch is just so much easier. How the hell, you might think, but it is possible. It has a higher initial cost, and you kind of need to adapt maybe a release process and tools, but you really avoid this merge hell also. So naming branches is one thing, but merging branches is just horrible. I think everyone knows that when you have been trying to merge two branches that have a lot of development on each. It's just really bad for quality also, because you end up with code that you don't really know how it's working. Has this been tested over time, and so on.
Yeah, maybe we can ask the audience.
Yeah.
Just curious, do you mean single branch? You usually want to have your own branch for you.
Yeah.
But you mean on the server, you don't have non-standing.
Right. Yeah, that's what I'm talking about. So what we have when we do code reviews, every code review is its own branch, and then you push it upstream to the master, and then you kind of retire that branch and you start over.
Yeah. So I was going to ask the audience: has anyone here been through a proper merge hell? Yeah.
Yeah.
How long-lived were the branches? Like 3 months or something, and then you merge, or longer? 6 months. Yes. Yeah.
So the only exception for this, in our case of Chrome, is like when we do a major release of Chrome, then there's a branch created, and then there's like very strict policy of what merges goes into that branch, only stabilization or security fixes, and then that branch just lives for that version. So there's no merging from the branch. Actually, it's just cherry picking from the master.
Yeah.
So to make this possible, you need to kind of, it can be tricky, but it should be doable in most projects, I think. You have these feature flags that you create, and that means like you have a flag that is disabled by default, and you enable it when you do your work, and you continue to work on your feature. The code is in there, but it doesn't really do anything for anybody else. And then when you feel your feature is getting more mature, you might want to start running tests with the flag enabled and disabled to get some comparison with data, depending on what kind of feature you're working on. If it affects the performance in a negative way, you might want to get numbers for that and so on. And then over time, when you have a go no-go meeting with a product owners, you kind of decide on, okay, is this feature ready for shipping? Okay, yeah, then we flip the switch, or maybe incrementally start rolling it out in some more percentages, and then eventually go to 100%, and then remove the flag.
How do you use this incremental stuff? I mean, how do you?
Yeah, that itself requires a bit of infrastructure, of course. I'm talking from Chrome's perspective, so we have something we call experiments, where you have like it's a central database basically where you kind of where the browser talks to, and then a certain percentage on certain platforms and so on gets like, okay, we're gonna just experiment with you, and then we see what data we can get in terms of statistics and data.
Yeah.
And then we look at that, and then we take the decision, okay, is this something we want to continue rolling out, or do we want to stop now and wait for some patch to roll in and get released, and so on. But if you're going to experiment with the users, you need some kind of beta program for early access, and that might not be applicable in all customers, I guess. Having the single branch also really simplifies the continuous integration, because you're building that particular branch, and you don't need to bother like setting up multiple builds for every branch that gets created, just to make sure you test it, because that's going to take a lot of resources.
Yeah, and it's pretty rare we actually run with flag on and off. We did it when we replaced the entire video engine in WebRTC, but otherwise we generally don't run it at all.
Yeah.
So how long does the branches live on average?
Well, in Chrome they live kind of forever, because we release like Chrome 47, then we cut the branch for that, and then it lives as long as you want, because when there's a version 48 coming out, that's just replacing that, and that gets pushed out to customers and so on. But in Chrome we work on a 6-week release cycle, so all the end users should get a new Chrome version every 6 weeks. So when they get a new version that is newer than the branch, it's basically useless, I'd say, because nobody's really interested in running the old version.
Yeah, but I mean, when you check out or start a new project, you create your local branch, and you do some dev work, and then does it live before you push it upstream to a master? Yeah,
then you discard it after your code review cycle is finished, and you push it upstream.
We don't have any numbers, I think, how long your average patch is worked on before it's turned into review, but it's...
Are we talking hours, days, weeks?
I think that's very individual, and depends on what you're working on as well.
Yeah, I mean, I would say most people probably a day or two, depending on if you have to wait for people in the US to review the code. There's a bit of back and forth that slows you down.
And some people just have an insane delta code line change production rate. They write a lot of code, but and some are slower, but both can be valuable. So yeah.
I probably have branches that are like 1 year old, but that's just because it's stuff that I started, but it never gets done, and it kind of sits there forever until I delete it. But that's not usually the case.
Yeah.
No other questions? Okay, a bit about testing and when to test. We really think it's important to do as much testing as you can before you actually submit the code. So in Chrome, we run a large subset of tests, of all tests, before a commit goes in. We even have something called a commit queue that you put, instead of submitting your patch, you actually just put it in a queue, and then there's a ton of machines that's crunching and testing with your patch. And if everything is green, then the patch actually goes in. But this can also be just a simple script that you run on your own machine as part of the the build toolchain you have for submitting the code. I guess that really depends on if you're doing multi-platform work or multi-browser work and so on. But it's an important thing to have to avoid this broken head problem, because even if you're very quick at rolling back, breaking changes in your continuous build, there is always going to be someone that just synced when it was broken, and you really want to prevent that at all the time. And in such a script, you should also have automatic lint checking, so you get at least a simple style guide checks that will just make your reviewer a bit annoyed and wasting his time. So you can cache stuff like that automatically by scripts. There's a pretty good set of lint checkers out there. So after there's a tiny example for how it can look in our code base. So this is when you upload a so-called CL change list to the code review server, and we have just a lint checker here for Python. So
I think this is what you should do, actually. Like somebody says, no, I want to put my braces over there because for religious reason 1 or 2, but sorry, the tool stops you.
Yeah. Style guides can be pretty strict about even white spaces and commas and so on, but I think it's a good thing.
Client format for C++ is very common.
Yeah.
Do you have any others tools like that for languages?
Yeah, we have a PyLint for Python and for Java. I don't know what it's called. And there's JS lint for JavaScript.
Yeah.
So I'm pretty sure there's lint checkers for all common languages.
Formatting that changes the formatting.
We have that for some things.
Yeah.
Go is a good example. I mean, that's really how it should work. Like you run Go FMT on everything and you're done. No discussion.
Yeah, or just have a part of the pre-submit that does run it, and if there's a diff against your patch, it's just going to complain like, oh, this is not properly formatted. Run this command and try again.
Yeah, there are even some tools like ASA which just removes the white space without asking.
Yeah.
I used to work on a project that was 2 code base. We had this client format just running on the code base, and it worked very well. So
yeah,
we didn't have any issues with it. It took away a whole lot of this discussions.
Yeah, exactly. If you have a system, then it's much easier. And even if you think it's really hard to introduce it, you can just have it apply on new patches, and then you kind of get it over time. But I guess it depends on the project. Moving on to this. Yeah, this is how the bots I talked about. So in Chrome, we build on many different platforms: Windows, Mac, Linux, Android, iOS, and so on. So there's a huge set of machines that runs tests. So in this particular case, this is the code review tool we're seeing here. And yeah, it's a fairly large patch with 20 files changed and so on. So this only failed on Windows XP, and that's really not a platform you want to work on. So it's really nice to have this machine that just does it for you, and it will tell you what went wrong. And yeah, that could be tricky to debug though, if you don't have a machine and so on. But
you may ask, why do we test on Windows XP? It's reached end of life. Only a very large percentage of Chrome users are on Windows XP. It's one of the biggest operating systems, actually. So we need to test on it.
Yeah, it's fun to support it just to annoy the vendor of the browsers.
That's what we do.
And after your patch finally goes in, passes all the checks, I guess most projects already have a traditional continuous integration where you run like all the tests, and hopefully you also run more sophisticated tests like memory tests and performance tests and so on, and gather data over time for what goes in there. That was the last piece of the code health pillar. So now Patrik's going to tell you about the next one.
Yeah, debugability. So yeah, you want to like be able to apply different tools to your code and analyze what it's doing. So I'm going to give you an example. So the Hangouts backend consists of a bunch of different servers, like many servers, tens of servers, right? And they all interact with each other to make Hangouts work. The video chat we're running now goes through one of the prod servers, for instance. But I can bring that up actually through some hard work on my workstation with a single console commands, and it takes about 30 seconds to get those servers up on localhost. And normally they don't run like that, of course, but they run on a machine each in the cloud somewhere, but or many machines each actually. But I can run it on my workstation, and I can hand send RPCs to any of their servers and see what it responds with. And I can look at logs in real time, and I can take a build I have on my mobile phone of the Hangouts app and connect that to local hosts to test stuff. Or well, you can. Oh well, I don't know. Yeah, you can do that. I mean, this kind of thing is very, very useful for debugability. And I mean, all programs are different, right? But I think you can do this with some effort for most kinds of programs. Another example from Ericsson, I was working on the 3G simulators, and that code only executed on this huge cabinet of RNC hardware that is Ericsson custom. I couldn't run it on my workstation, so that meant you had to take turns to test your stuff on that hardware. And that's not a great situation to be in. So for servers, how do we do it? Well, I can't go into detail, obviously, but we use a Python framework, and really what it does is invoke all the server binaries with the right flags and ports and stuff, and make sure they can talk to each other, or that they talk to each other and not a prod server somewhere. You don't want that. And also, if it uses databases, that it doesn't hit the prod database, that would be bad, probably. But that it hits a local database you have on your machine and that kind of thing. So we have that framework to bring everything up, and then obviously you need to write all the servers so that they are configurable enough to be able to run on your workstation, and also scalable enough in resource use and stuff. So it's not hard-coded to a database, or it doesn't require 64 cores from the start, to even run and stuff. So, but that's a good thing to aim for. Another example of where it can be hard to run on your workstation can be mobile development. How many here do mobile development? Mobile is hard, right? It's really challenging for a lot of reasons. But there are a few things you can do. I think the most typical setup people use is they have a phone, a USB cable, it goes into your workstation, and then you install the app onto the phone, and you click around in your app and see that it's doing the right thing. There are a few things you can do to make this easier. One is emulators are actually surprisingly good, at least if you can build your app in x86 mode, because if you need to emulate ARM code on x86, it's going to be slow and it's going to suck. So, but if you can build an x86, it's going to be fast, and then that's awesome. Even better is Robolectric unit tests, because then you cut out Android entirely. Robolectric runs in a JVM, and it pretends to be Android, and it looks like Android, but it's just a big sort of scaffold built around. It looks like Android. So then you can test your mobile app code in unit tests, and it can run directly on your workstation. You don't need a phone or an emulator, even, as you would with an instrumentation test. Another option that we managed to do with one thing at least is to, like, suppose you're writing some functionality that you're going to use in a mobile app. Maybe it doesn't actually require Android primitives, or at least some of the code. Maybe you can put that into a library. And if it's just Java code, then you can write a command line app, for instance, that you can exercise your code through. Or you can maybe write a big integration test or something. That's pretty useful. Then you can run your Linux workstation. You don't need to keep your phone plugged in and in the right state. And and also setting up your app so you can debug it and getting into the debugger is useful. This may not be possible for everything, but for most things you can do it. Like the JavaScript debugger in Chrome is really good, for instance, so you can debug that. There are a lot of good debuggers for C++. and so on. Debugging can be hard in some cases. Like if you have a multi-process app, like Chrome, for instance, it runs one process per tab, really. But it's doable. Like you can debug Chrome with clever use of Xterm and some flags and GDB, and then you can kind of choose what render process to debug, and with some trickery, it's doable. And even if you don't get the debugger attached, something to ensure pretty early in your app is that if you have C++ code, at least, is that you get good stack traces when something crashes. This is something we had to struggle with a lot, actually, that, I build and debug, but yet I don't get the symbolized stack trace. I just get a bunch of numbers, and that's very hard to understand where the error happened. So you need to build with symbols, really, to make that happen, even if you run J&I code in a mobile app, for instance. And another thing to think about is, like, when you release to customers, you generally build optimized without symbols, but it can crash anyway and give you a stack trace. Then it's good to save the symbol information somewhere. We have a few internal tools that does it. Like, we got the crash from this version of the product. Here are the symbol files. We symbolize the stack trace, and then you get lines and function numbers and stuff, or function names, I mean.
All right. That's pillar 2. So now I'm going to tell you. Oh, sorry.
I have a question on debug.
Yeah.
Yeah.
For instance, how do you debug problems which are probably, like, for instance, concurrent problems or issues which happen in the interaction? Do you have any good, not good ideas, but do you have any common techniques that you use? Or thoughts around this? Like, for instance, things going wrong only in production, but which work fine in developer environments, like, so probably they're not covered with unit tests or even end tests.
Yeah, there's always going to be stuff like that. It's hard to deal with. What you need is good logging and statistics, like user statistics if possible. Like for people who opt in Chrome, they upload crash reports to Google, and that's tremendously useful for us. That's one way. And then even if you can't reproduce it, which you most often can't because this happened because of a bad graphics driver in Windows XP somewhere in China, you can't reproduce that. Well, at least you can reason about how common it is and if you need to fix it. So I think in general there's that. And also, like Henrik mentioned earlier about rolling out experiments, if you see statistics start to change for these users, like slightly higher crash rate, then maybe you have a problem. But it's a hard problem for sure.
The owner of that part to get it back into a decent state.
Yeah. The best thing is if you can see, okay, a change happened here, and then the test went flaky. If the sheriff is really on point, then you can revert that patch instead. That's a lot better if you can do that, but it's hard, really hard.
Yeah, and that requires a bit of infrastructure as well. In Chrome, we have something we will call the Flakiness Dashboard, which is kind of a view over many builds, so you can get a good tool to see the trends, like, oh, no, this test started failing, should be in this range-ish. And even if you're not sure like when it started, you'll just file a bug and give the data you have, and then let the developer do the rest of figuring it out. Having reliable machines is also critical, because it's really annoying when it's a machine failure and so on. So really try to use virtual machines as much as you can. In Chrome, every machine reboots entirely after every build, even the Android devices and so on. So that's really the key for really ensuring that you have the exact same state when you start compiling and run tests. A bit of a buzzword in the testing communities recently is this continuous delivery, but it is really a good thing to be able to release frequently, because you get these smaller deltas of changes, and everything is just so much easier. Also, if you miss a push, then you have the next one pretty soon anyway. And being able to do this in a very automated manner is key. You shouldn't really have to rely on, okay, now we have this release ready, and now we're just going to send it to this manual testing team that sits for for days or maybe even weeks testing it thoroughly. It shouldn't be like that. They should be able to focus on what's new in this release, and maybe even have it fully automated if you're confident that you have enough test coverage. And having that also allows you to have the short release cycles, which means less code goes in for every cycle, and you can avoid this dangerous for quality ski jump effect. That's like everyone wants to get their stuff in when the release is coming, and that's a disaster for quality, basically. So yeah, having this really makes it easier to do things, and it encourages the hackability in the project. A little bit of dependency management. I think many projects today really uses a lot of the good open source libraries that are out there and so on. But in many cases, it's just like, yeah, somebody pulled this and that version in, we just checked it in, and then it just stayed the same forever. I think it's really critical to, in these days of security and patching, to really have a strategy for how you handle all these dependencies. So you should have a system that allows you to like version control them. You should be able to do builds with the newest version and so on, so you can really benefit from security patches and so on. So having that worked out is also critical for like staying up to date and move fast. Some examples of this could be Maven or G-Client, which is the tool we have in Chrome that is custom made for Chrome, but can be used for anything. And the final thing I was going to mention is documentation. Documentation is, everyone thinks is boring, basically. So we try to keep it at a minimum at Google. But it's really just a few lines of comments or documentation can be really useful for understanding the code, and that's what documentation should be about. So it's critical. Question first. I think both are useful. What goes where? It's kind of hard to generalize, I guess. I mean, if you have a good source control system like Git, you really can easily just annotate the lines or git blame, and then you can trace it back to the code review, which is also a good place for documentation, in my opinion. I use that a lot.
Yeah, I think in general, comments are for what the code is doing right now, whereas commit messages is why a change happened.
Yeah.
And that's an important thing to put in there, not hack or deal with it or whatever. You know. Should be, why did you do it? And then when somebody goes back and looks, oh, this broke everything. Okay, he did it because of that. Well, okay, well, that was a good reason at least.
Yeah, and when you have code review, what you write in the like description of the code review is actually your code commit message. So the reviewer will complain if it's bad. And that's how we have it, at least. Yeah. But if you want to have additional documentation, 2 comments, it really should be text-based, so you can diff it and track changes, and also see like who wrote which line and when with git blame. And examples of that is Markdown and JavaDoc, if we're going to mention something older. We put a lot of readme.md files everywhere in the source tree in Chrome, just to kind of explain like what is this directory for. And when you have it automatically generated and browsable through a web interface and so on, we think it's really useful. Chrome recently moved like all their wiki pages down to just Markdown files that are checked into the source tree instead.
Oh, and that's something we should mention as well. Codesearch.chromium.org. You can search all the source code in Chromium and read all the source code in Chromium. That's an amazing tool. So essentially, we have a bunch of machines that crawl the code whenever a commit is made and indexes it so you can search it. That is super valuable in large projects because you can't. Chromium is too big to search in the IDE. The IDE just breaks down like Eclipse or whatever. But code search.
It's 60 million lines of code.
Yeah,
last time I checked.
It's a lot.
But that said, I'm not sure. Is that an open source? Can you like deploy it on your own?
I don't know.
No, we have to look that up. Yeah. But yeah, it's a very critical tool for every engineer at Google.
Yeah,
we have basically the same internally.
It's almost as critical as Stack Overflow.
So
that wraps up our presentation. So thank you.
So yeah, why don't we take a few questions now, and then we kind of continue the discussions like in smaller groups or in the cafeteria and so on. So is there anything? Yeah.
So when we are talking of infrastructure,
I can try to repeat the question.
I can.
We have mics. Hold.
When you're talking of infrastructure, what's the sort of opinion? Do you prefer having small services which do small things, or do you have bigger services which do more sophisticated things? I mean, is it easier to maintain some like the smaller services compared to the bigger ones? Is there any preferred way of doing it?
You mean in production infrastructure? Yeah.
I don't even know. What do you mean by services in this context?
So, for instance, do you have smaller projects which run independently? But so, for instance, do you have? So, if I were to take an example, like for instance, does Hangout or something like Gmail depend on a bunch of other services which are sort of like microservice in some sense, or does Gmail have its own sort of infrastructure which sort of supports it completely in some sense,
Yeah, well, in general in Google, I mean, there's a lot of systems. There's like storage systems, like huge databases and so on. So of course, each of those systems should be tested individually and try to keep things doing one thing. That's a great golden rule for software development in general.
I think it's a trade-off, probably how big you make your individual server or whatever. We're probably not the right guys to ask, but I heard one interesting thing a developer said once, and that is that he managed to rewrite the server from 25,000 lines to 5,000 lines. It was 30% slower than the other one, but he said, I'd rather take the second one because I can just add more machines. It's less code. It's easier to understand. So little code, less code is always better than more code.
Yeah, we even have developers in our team that are competing with how much minus lines of code they have written since they joined.
We have one guy who was in negative. He's really proud of that, and he should be.
Yeah, I think it's a negative 50,000 or something.
Do you automatically enforce all your process from I'm writing code on my machine to your process from I'm writing code on my machine to this has gone to someone, this has gone in a pull request to someone for code review, up to now it's integrated into master. The process for that, you mentioned that each project has its own linting tools, it has all of those sorts of things. How much of that is automated, i.e. you can't push it until it's gone through the linting? Like or how much of that sort of relies on someone following a process, like being sold on that the right thing to do is to lint it first and then push it? Do you automate that out, or do you allow people to?
Well, a lot of the things you can automate is automated. I think like linting is an example. Yeah. You can bypass them if you think you have a very good reason, but if you keep doing that, people are going to get angry with you probably. But I think the main thing that ensures quality is review, where humans look at the code. No, that passes lint, but it's stupid. Don't do it.
Okay, and is it possible to bypass review?
Yeah.
Yeah. So you can. Okay.
But if you do that and get caught, or if you do it a lot, then people will get angry with you.
Yeah, I mean, everything is traceable, and I think depending on the system, in Chrome you can bypass it as long as you're a Chrome committer. I mean, not everyone can just submit code and bypass it. You have to really be part of the project.
Yeah, but you'll quickly lose that status if you're irresponsible. So, yeah.
But internally, if you're going to bypass, it's a bit harder, and you always have to specify at least someone that will get an email, so they can review it afterwards. And that is like the common thing to do in Chrome as well. If you just do a one-line fix, just to unbreak something, it's okay if that person reviews it after it goes in, because if the build is broken, it kind of stops too many people. In Chrome, we have like 300 commits per day, so you don't want to queue that up.
More than 1,000 developers, and it's a lot of lost engineering time to break out. So,
yeah, small question. How many reviewers do you have on average on like a review? Or how many people look at your code in a review?
1.1 maybe.
Usually just one. No?
Yeah, I'd say so. I guess it depends on, but yeah, probably on average, close to one.
Yeah.
You try to keep it small so you don't touch too many places in the code base, and then you end up with one. And it's also something you adjust yourself, because if you're doing less, you get a faster review, and then you can get your code in, and then you can start working on the next thing.
Is picking a reviewer automated, or can you pick one yourself?
No, you pick one, and it needs to be one who is owner of the code. Like at least one owner needs to approve, and at least one readability expert needs to approve. And if you have readability already, you don't need readability approval.
Yeah, you can pick one yourself, but you get suggestions when you upload, like pick this guy, pick this guy.
So
random.
Yeah, some people do a lot of reviews. And also you need to watch out and team a bit for the buddy reviewers problem, which is where two people just assign each other and are kind of too nice in their reviews. Me and Henrik are certainly guilty of that. So.
Question? The mic?
I don't think I need one.
Okay.
I'm a big fan of disks.
What do you think about this? Is this a good thing? And then you might just throw it away, or just continue iterating on it and send it out for review eventually. That also happens.
So when I worked at Spotify, we used to do code reviews where the entire team gathered around more or less each review and had a big discussion about it, which turned out to provide a lot of learnings for everyone in the team, just not only to approve the code, but also to learn about different parts of the system and learn good programming practices. You do any kind of that? Yeah,
well, if it's like more of a larger feature, we usually create a design doc, and then we have design reviews instead, where like some part of the team gathers and have a hangout, and they give a presentation about the doc, and everyone has been reading the design doc in advance, and then they discuss different solutions and possible design problems and so on.
Yeah.
So, but that's not really like tied into this code review system. This code review system we've been talking about is like on a per patch basis.
Yeah,
usually just like 100 lines. Changes.
And I get the feel like you're doing more on an approval level than on a team learning level.
Yeah, well, I guess the design review there is both.
Yeah.
Like you can both learn stuff and contribute to the design, but talking about a single patch like that and on a lower level about writing code, I think that's a great idea. I can understand that it worked. It's a fantastic country.
It's quite common also, like that somebody's interested in something, so then you just CC that person on the review. And we also have, like, the code review is integrated with the bug tracker. So you mention a bug in the code review, so then after it gets submitted, there's like an automatic post on that bug, like, now this change was submitted regarding this bug, so everyone that's subscribed to the bug also gets a notification like, oh, something happened here. and then you kind of get the traceability that's useful for when you should test this, if you need to do manual testing and so on, and close the bug eventually.
It can be interesting to follow big bugs, and then, oh, here's the fix coming in, and like, oh, that's a clever solution. That's kind of, so you can do that. But, yeah. But no, we don't do anything directly like that. But I think it's a great idea.
Yeah.
Yeah.
Over there.
So you mentioned how you implemented this small unit tests at the beginning when a project started, and that encouraged kind of unit testing to pick up and so on. But what if you just joined a bigger project that doesn't have, let's say, good practices in place? How do you build that environment? Like, what would be the first steps?
That's very common as well, and then you're in a trickier position. But there are two things you can do. I think the easiest thing is probably like when you start writing new code, that you test the new code. So you write a new class, for instance, then you write the unit test for that class, and then keep pushing the practice like that. And then when you get a bit more sure about that, then you start refactoring the old code so it can be unit tested as well. That is really the way you approach it. And the additional refactoring, it also takes a set of skills that takes a while to acquire. There are books that are about refactoring legacy code and adding unit tests, which I would definitely recommend. And once you manage to do that and get more people on the train and then show like, hey, I was able to develop this much faster because I had a unit test. I didn't have to start the 2-minute server to see that my code worked. You know, other developers are going to notice, and then you can encourage them to get on board as well.
You mentioned books. Which one would you recommend?
Oh, books. There are a lot of recommendations.
Okay.
Well, I think when it comes to legacy code, I mean, that depends on, I mean, about writing unit tests, there are a few books. I would recommend Growing Object-Oriented Software Organically, I think it's called, or something like that. It's a book by the guys who wrote JMock, and it's a really interesting book about software design and how to write unit tests and stuff. So that gives you the kind of ideal vision of what your software should be like. And then there's refactoring, a book called Simply Refactoring. That's great to use to build your toolbox about what refactorings you can use. And then there's refactoring legacy, or working effectively with legacy code is the third book I would recommend. And that one directly addresses the problem head-on that you were talking about, like how do you take a huge legacy code base that don't have tests and make it testable over time. And I would say that book is pretty conservative in its approach. It's very careful, so that's the most careful approach you can take. I would go a bit more cowboy than that, but you know, that's up to the individual, of course.
We could add a reference slide to the deck here for those.
Yeah, before we send it out, absolutely.
Yeah. I should also mention, like, it really depends on the team culture, like how senior developers are thinking about stuff like that and so on. So it can be hard to encourage people to really change the direction, but I think the kind of guerrilla way of doing it yourself and then kind of showcasing, like, look what this did, look what this did, and if possible, you should also try to collect data so you can really prove it.
In fact, I did just that at the project at Ericsson when I was pretty new. Of course, we were writing unit tests, and I started adding a bunch of tests, and people did not like that. I received a lot of pushback, especially from senior people that thought I was, you know, they are older than me, so therefore they are better, and that kind of thing. But I just tried to push through, and in the end, all people except one eventually really appreciated that. You know, so if you take initiative and drive that kind of thing, awesome things are going to happen. But fortunately, I wasn't alone in this. It was me and a few other people that really drove starting the unit tests. And if you can do that in a project, you're a tremendously valuable person.
You mentioned that you could easily deploy like 20 server deployment of the Hangouts on your local host. So I was a little bit curious. Do you do that using containers, and do you do that in an integration test context? Automated tests?
Sorry, what?
Yeah, automated.
Yes, absolutely. So no containers. It's just C++ programs that are invoked by Python scripts, and then they start up and they start doing their thing.
So you have to keep track of ports and everything for config.
The Python script does that for you.
Yeah.
So it allocates ports to each server and makes sure the right servers get the port information.
So that's something you have developed internally. You don't use.
Yeah. And that framework is fairly simple, I would say.
Yeah.
It's just binaries and ports, really. And as for automated tests, yes, we do use that, and that's what enables us to run Hangouts tests in pre-submit, because if you had to instantiate your test across several machines, or like, I need 15 machines, one server for each, and then connect to each and run a test, it would never, ever work. Like, the network would be slow on this particular day to this server, and then the RPC times out and the test fails. So you need hermetic tests, which means it runs on one machine, always one machine, for anything except the biggest, most enormous end-to-end test you can imagine. So that makes it possible for us to bring up a backend, run a Hangout locally with the local Chrome browser, connect to there, get into the Hangout, and ensure it actually works. We do that, and it runs in pre-submit for every single patch.
But it does require a pretty beefy machine, though.
Like
not 2 gigs of RAMs here.
Those particular tests are very, very, very expensive. So you need a lot of machines.
Thanks.